Good morning, good afternoon, good evening, wherever you are, and welcome to the CI Compass webinar series. Today, we are hosting Bob Flynn, Program Manager for Cloud Infrastructure and Platform Services at Internet2. And my name is Jarek Nabrzyski. I'm Director of the Center for Research Computing at the University of Notre Dame. And I am also one of the co-PIs on the CI Compass grant, grant award. So, Bob, maybe let's start with kind of closer introduction of you, what you do at Internet2.
Sure. Thanks for having me. This is great. And it's a lovely day here. So I'm sitting outside and they've just decided to start tearing down the house next door. At least that's what it sounds like. So hopefully that won't interrupt us. Yeah, I manage our cloud infrastructure and platform services portfolio in the Net Plus program at Internet2. And what that means for practical purposes is I run currently our AWS GCP programs, and we're also doing an evaluation of Kion, which is another tool that people use to support their cloud infrastructure. And I'll talk more about Internet2 in a general terms in just a moment.
Yeah, okay. Thank you. Let me maybe first say a few words about the idea of this webinar and why we're doing this. So the CI Compass is an NSF Cyber Infrastructure Center of Excellence, and we engage with NSF major facilities. Many of you here in the audience probably know about us. For the National Science Foundation major facilities, the data processing captured at the edge is sometimes very, very difficult and very expensive. And some major facilities like SageGauge, for example, are moving their workloads and pipelines to the cloud. And so we've been engaging with these facilities to help them. One of the things that we've done as CI Compass, we have developed a data lifecycle model that identifies specific stages of the data flow. And this is also very relevant to the cloud, to our pipelines in the cloud. So this is becoming very relevant to major facilities, and we'd like to expand our knowledge about cloud and how what cloud offerings are available to us today, and how major facilities and others can move to the cloud. So this is really again, it will be very high level, but we would like to discuss some of the problems when it comes to cloud adoption, etc. So Bob, maybe let's start with a short introduction to Internet2.
All right.
Okay.
So for those of you not familiar with Internet2, I'm just going to run through a few basics. So Internet2 is the National Research and Education Network for the US, the NREN. And we support a great deal of the higher ed and research community in the US. And you can see here a few stats about our involvement in the community and our work. Let's see. So the core things that we do is we supply the high-speed internet backbone that connects much of the research and education community in the US. We supply the identity framework that is also used by much of that community, and I'll talk more about that. And then we do a lot to support the use and adoption of cloud in the community. And a lot of this is done not only just in the technical implementation level, but we also work very hard to convene the community to help create common solutions that no one individual group would be able to make. Some crossover between the work of CI Compass and Internet2. Recently, there was the CI Compass Federated Identity Management Cookbook came out. And also we're working with NIH in the expansion of their login service using In Common. So We're very involved in the research community in enabling your work. So just a kind of a broad overview of what Internet2 does in the cloud. I mentioned connectivity. I mentioned identity and access management. We're also expanding our training programs. We have significant community engagement work going on. We aggregate community requests and feedback to the vendors. So we work with the cloud vendors and help broker those conversations. And we convene members of the community to vet services for the greater use of the community as well. On the networking side, we have a number of services we provide, and we partner with AWS and Microsoft and Google and Oracle in our Cloud Connect to allow the dedicated connections, direct connections to those providers at no additional fee. So these are, I'm not a networking person. I'm not going to pretend that I can go into detail on these different levels of service, but these are available to this community. On the identity side, I mentioned earlier, we have In Common, which is a national identity and access management framework. You may be familiar on your own campus or institution with Eduroam. Eduroam is a worldwide wireless standard that allows you to leverage your own institution's credentials to log into wireless points around the world. And we also partner with Gayant on the international identity space as well. Then in the Net Plus area where I work, we have, I mentioned our training programs. We have a class program, and those are rapidly expanding. The Cloud Scorecard, which is a program that sets a standard questionnaire for vendors to fill out to provide information from their accessibility to their pricing to their security, all allows you to evaluate various vendors in a space. If you're looking for a solution, it's a good place to start. And then the Net Plus program, where we pull together the community to, as I mentioned, to evaluate certain high demand services and create contracts that have been vetted by your peers in the community to save you time in terms of evaluating and signing those services. And really it all comes together in the Net Plus program, where we have the part of the contracts include the connection for the vendor to the peered network. We ensure that they're adhering to the identities and security standards. We set up advisory boards to convene or to converse with the community around and the vendors to move it forward with the priorities of the community for getting items on the roadmap for those vendors. So that's kind of a very high level overview of Internet2 and of the work that we do to help support your work in the cloud.
Thank you very much. This is very helpful. So cloud is really a very big word, a very encompassing word. So what do we think, or what do we mean when we say clouds in our context here?
Well, yeah, it's an overused term. And in fact, last year I wrote a blog post about when can we stop using that term, because it really is a bit overused. For the purposes of this conversation, we're talking about infrastructure and platform as a service. Folks are familiar with a lot of software as a service, whether that's Google Drive and Gmail, or Box and Dropbox, or Canvas. Software as a service, you're essentially surrendering control of your data in exchange for innovation. We all remember the days where we built everything on-prem and there was instantly a lot of technical debt and maintenance involved. Well, with the advent of software as a service, we've We've certainly handed that off, but that's handing off control of your data as well. With infrastructure and platform as a service, you have the powerful tools of the cloud, but maintaining responsibility of the data and security of the data is your responsibility, and the innovation is on you. The tools are there, but it's up to you.
Yeah, very good. Thank you. So many universities have moved already through cloud first, their enterprise computing to the cloud. How about the adoption of the academic community, of the researchers, and is really the cloud adoption constantly growing? What do you think?
Yeah, so the academic community has been slow to adopt cloud, with some notable exceptions. I think early experimentation by adventurous IT pros and CS faculty really started to open the eyes of some, but there was a lot of fear of the kind of the cloud boogeyman of cost and security and even job loss for IT professionals. But I think increasingly researchers, encouraged by the sometimes generous support from the cloud vendors, began to really embrace the tools and opportunities that the cloud platforms with their limitless compute on demand has really pushed the innovation on the cloud side and academia to researchers. And this increased use by research faculty has forced institutions to, in some cases, scramble to keep up with the researchers. I think this has led to a gradual increase in the organizational cloud IQ of a lot of institutions. Naturally, there are also some IT professionals who have been early adopters. And I think your institution, Jarek, Notre Dame's a great example of a grassroots demand from the IT professionals there to move the institution as a whole to a cloud-first institution.
Yeah, that's true. So the last 2 years were very hard for all of us with COVID. What kind of impact did COVID have on cloud adoption in academia, and has it accelerated or slowed down this adoption?
Well, I think first and foremost, it accelerated due to the quick shift to work from home. And so whether it was the acquisition of hardware that was slowed down by supply chain issues, or just the need to pivot to virtual collaboration, I think there was a lot of increase in use in cloud. Certain disciplines saw massive investments in the form of cloud credits. Certainly, all of the cloud vendors, the major cloud vendors, put money out there for COVID research. We had one Duke researcher working to model airflow to allow the sharing of ventilators. This came with assistance from the Microsoft research team, and they were able to spin up a cluster in 24 hours that allowed her to run 8 to 100,000 compute hours in just 72 hours. So this was really a remarkable story and remarkable demonstration of the power of the cloud. Another example is there was a self-described group of nobody junior researchers who used AWS to search over 5.5 million biologically diverse nucleic acid sequences from a public NIH data set, and they identified over 10 to the 5th novel RNA viruses. And they did all this work in 11 days at the cost of just under $24,000. That's published in the article in the journal Nature, and I think they'll share that link with you.
Yeah, Jason is in real time putting all the links for you all to study further.
Excellent.
Thank you, Jason. Yeah, thank you. Very interesting examples. I run the Center for Research Computing here on campus, and I have several of us are here also. We have always researchers coming to us and asking, why would I benefit from the cloud? What are the characteristics that would be good for me to use, and why would it be interesting for me to move my workloads to the cloud? So can we talk about this, characteristics of the cloud and what are maybe most suitable candidates, workflow candidates for the cloud?
Sure. And just before I talk about research, I want to briefly mention it's also a good tool on the teaching side. So
Yeah.
just kind of the on-demand and ephemeral nature of cloud has proven to be really useful. So at my old institution, there was a database design course that they needed once for I think 2 months a year in the fall semester. And for years, they maintained a server that was only spun up at that time. And so to be able to create something like that in a container, spin it up in the cloud and duplicate it as many times as you needed for the students in the class, and then just make it go away at the end was a really nice use. On the research side, it's even more interesting because you have this nearly limitless compute power, and this can really vastly accelerate research. Projects that would take weeks or months, even on local supercomputers, can be done in hours or days on the cloud. The challenges that come with traditional queues don't come into play with on-demand computing. The variety and flexibilities of the tools themselves allow the researcher, and I've got this great quote. I was recently at an AWS event, and Rick Friedman, who currently leads academic research and for AWS, said, it allows the researchers to build the box to fit the problem versus defining the problem to fit the box. And the box here being the computer, of course.
Yeah.
So I think that's a really strong indication. So I personally I'm not a research guy. I'm not knowledgeable enough about the full spectrum of research workloads, but I do know that there are some obvious ones, like embarrassingly parallel workloads, like the one I mentioned before with the NIH data set. And one that really just kind of took my breath away. Researchers at Clemson essentially created a recipe for an on-demand supercomputer. And they did this, the use case was for rapid disaster response. They processed 2 million hours of traffic cam video in 4.5 hours to help emergency coordinators direct evacuation routes during a hurricane situation. So that kind of compute on demand is just stunning. You've got an NYU researcher using Google Cloud to analyze genomics data in order to find diagnoses of rare undiagnosed pediatric diseases. And I saw a presentation by an MIT researcher who was analyzing data coming off the Large Hadron Collider at rates of 1 petabit per second and processing that as well. So normally I would say the not so good use cases might be the ones that require a lot of GPU, but that one with the Large Hadron Collider actually was using GPU. So
Yeah.
GPU is expensive in the cloud. I do know of another case where there was idle GPU that was loaned to a research project. But in general, I think that's at the other end of the spectrum where it's more expensive. So I personally think as a community, we together, the research community and the cloud community, need to compile a list that provides this kind of guidance to researchers. I'm sure it's going to evolve over time because the tools are constantly evolving, but we should be able to provide, better guidance. There's nothing cookie cutter, of course, but we should be able to provide better guidance on this.
Yeah, and I guess similar to GPU would be truly high-performance computing workloads. They'll be probably very expensive in the cloud. And cost of computing and storage is always a big question, right? I mean, as well as data transfer, these are big factors for researchers. And, the big question is how can a researcher control their costs in the cloud?
Yeah, that's always a big question. And I referenced earlier, well, I'll just say education is number one. And there are some good resources out there. There are certainly ways to avoid obvious cost overruns. One thing that's different just in the cloud mindset is you turn things off when you're not using them. You build things so that they're they're fault tolerant, and when you bring them back up, they pick up where they left off. I think, as we discussed before, identifying which computing models are cost effective and which are not. You want to look at data life cycles for smart storage. So there are different costs for different storage tiers in the cloud, and some of the cloud providers have tools that will slowly life cycle untouched data to colder storage as it's unneeded. And then you mentioned data movement, data egress. That's one that is a source of a lot of confusion. And in fact, here at Internet2, we're working on a webinar for early in 2023, but we're going to send out a standard set of questions to the major cloud providers, ask them to respond to those so we can put together a resource for the community. And then at this webinar, we're going to also invite the vendors to come, and in breakout rooms, you can discuss your individual use cases with them. So that's the hope.
Yeah. In my lab, even though we have a very nice data center, we still do some, analysis in the cloud. We basically collect data from blockchains and analyze this data in real time. I was really very surprised when I looked at the, bottom line at the end of the month, where really computing wasn't as much expensive as the relational database systems. It was really surprising to me.
Right. And of course, there are different database models, and you want to make sure that, if it really is a challenge to move away from the way we've always done compute. When I was in my previous position at Indiana, a researcher contacted me once and said, what's it going to cost me to get 300 terabytes of storage on, I don't remember what platform he was asking about, but 300 terabytes of storage. And I said, do you have 300 terabytes of data now? And he said, no, but I'll build up to that over the years. And you don't start out with that mentality. So you want to leave your expectations at the door, I think, and come at it new. And I think we're going to talk a little bit more here shortly about how to engage the cloud providers to maybe get some guidance on those decisions.
Yeah, right. This is actually my next question. So there are already so many different cloud providers. They provide different services, and it's really hard to navigate through it. So how do I make a decision on which one is best for me?
Well, that's a what day is it sort of question, because the answer is always changing, and it's difficult to keep track of on a daily basis. But a couple of recommended approaches. One is there are a number of websites that go out there and compare the relative strengths of the vendors in various given areas. You want to kind of take some of that with a grain of salt, because sometimes there are consultants who are trying to push one platform over another. But there is useful information out there. You can also take a look at what the inherent strengths of the respective vendors are with what they do with their own technologies. So I'll give you a couple of simple examples. Google for years has had Google Earth, Google Maps, those sorts of things. Their image processing technology is I think second to none. So if you're using something like photogrammetry in your research, you might consider talking to Google. Amazon, we all know Amazon from their quote bookstore. But one of the things that's taught them over the years is the speed and scale of database processing. So if that's important to your project, Amazon might be somebody to talk to. So those sorts of things can help. But the main recommendation I usually have is to sit down and talk with the vendors themselves. Shop your project around. They are anxious to sell to you. So see what kind of advice they can give you. How would they architect your workflow? What can they do to accommodate the tools you're familiar with? What kind of cost projections can they give you? And if it doesn't matter with your workflow, what is your local team most comfortable with? So what kind of support can you get internally from your university? So I think also there may be some business model options that come into play. So for example, Google has a subscription model where once they sit down and work with you to map out the workflow, they'll give a cost prediction, and then it will hold to that for the entire year, whether your workflow goes above it or below it. So you have predictable pricing. It really depends on your needs. And then finally, I would say leverage the higher ed cloud community. There's a tremendous amount of expertise out in that community. And it's a lot of people who are supporting researchers in a lot of different situations, and they're there to help.
Thank you. That's very helpful. And then we also have you, right? So how
Yes.
Internet2 can help us? If you could kind of, with making this right decision, how can you, if you could summarize again what Internet2 can do or how they can help?
Well, I'll tie this back to the project that I think, Jarek, is how you and I met, and that was the Sage Gauge project. And basically we started out just talking through the organization's workflow and help them familiarize themselves with the vocabulary and what that might look like in the cloud. Help brainstorm on the right questions to ask the cloud providers. We can then connect you with the right connections at the cloud providers to talk through your workflow. And then we can help train your team when the time comes to whether it's the basics of the, as I mentioned, the vocabulary around cloud or financing, and up through hands-on training with some of the skills as well. And then somewhat ironically, we've also assisted in connecting researchers to their local cloud enablement teams to make sure that they've got that home team at the table supporting them. So that may differ between an academic institution and a major facility, but you know, your IT team should be there backing you up as well.
Yeah, and you know, usually in researchers' teams, the cloud IQ is not always there, and it's one of the barriers to entry. And there are many others. How do you go about that?
Yeah, this for me is fundamental. As I mentioned before, I used to work at Indiana University, and my mantra was, if you don't understand cloud, you can't make intelligent decisions about it. And so having that basic understanding of the cloud model, the cloud vocabulary is essential. I think there's some tremendous basics resources out there right now that were developed for a cloud bank by Rob Fotlin at University of Washington and others. There is, they've got a nice terminology glossary there, but a number of resources that I would certainly recommend. And then, as I mentioned earlier, you should kind of leave those expectations behind, be willing to experiment kind of clean slate on the cloud, and consider, you know, each of the cloud vendors has a free tier. Go in there and experiment with it a little bit, scale as you go, and you know, just don't build anything in there you have to have in the free tier, because it may not migrate easily over to production when you need to. But I'll also, you know, say one for my compatriots in the cloud enablement community. You want to connect early with that cloud team on your campus. In many cases, they might just be the ones to get you accounts and up and running, and they can hand you off to cloud friendly, you know, the RCD team, the research computing and data teams that support the researchers and are cloud versant for you.
No, true. That's true. Yeah, in our you know, own CI Compass story, and how we connected to major facilities who required cloud expertise and cloud support. It was actually probably a year and a half ago with it was with Sage Gauge, who were basically required to join forces and to develop a common cloud platform, what they call it, because they're decided, or NSF decided, that these facilities should be moving their data and infrastructures to the cloud. So for us, the goal was to help Sage Gauge through our engagement to explore the different options, various options for designing and deploying cloud platform. and think about data cloud processing, storage, sharing with the scientific communities, etc. Very broad, and it appeared to be a huge project, and I think this project is still ongoing. We really, number one thing that we wanted to do was to really help SageGauge understand the risks of cloud migration, risk associated with every vendor, and what kind of risks the project should be looking at, and then how to potentially mitigate these risks. The big concern for this facility was, of course, the financial impact, especially egress cost. And, you know, it was very important to understand, very, very closely predict with a good accuracy of what this cost for this particular project would be. So this work is ongoing, and I'm sure we have many SageGauge partners here. But what is important maybe is that we also help bring all the facilities together to discuss about cloud infrastructures. We have a working group that spans across many facilities, and we have members from major facilities in this group. And if you're interested in joining this group, we'll be very happy to talk to you, and you should contact us. So yes, but we as a project, you know, we are an NSF Center of Excellence in Cyber Infrastructure, really focusing on data lifecycle. We have been learning a lot through this process, and the good thing is not only the PIs and the team of the project, but we have, you know, larger teams behind us. Like I run the Center for Research Computing, where we have, you know, 50 plus research computing specialists and support. We have also friends in the OIT here, the Cloud First, who always are a great help for us. So it's not just us; it's a larger community that we bring to the table. Yeah, maybe let's talk maybe a little bit about the steps for a successful transition to the cloud. What steps we should take, or a researcher should take, or a project should take when thinking about transition to or migration to the cloud.
Sure. Before I ask that, I want to comment briefly on your previous points, and that is the issues surfaced in the SageGauge project are a great example of the feedback we take to the vendors and show them the obstacles to adoption and the issues that they may in some cases think that they've resolved and really haven't. And sometimes it's a disconnect in the conversation. And so that's certainly a role that the higher ed cloud community in general, but in my role specifically, it can help with. So I just wanted to point that out. And I am working within that the working group that you mentioned, and we are working on some documentation to help guide the community as well. So in response to your question, in terms of a successful transition to the cloud, I think, well, certainly all the cloud providers are eager to help you. I think that goes without saying, but it's vital to understand that whether it's a commercial cloud provider or an academic provider like Jetstream, they're providing you tools. So cloud is not a religion. It's a set of tools. You're not either all in or all out. Just like anytime you approach a problem, you want to have the best tools available. So mix and match. It might be some of your workloads on-prem and some's in the cloud. It might be some of your tools are on one cloud provider and others are on another. Don't get locked into any one vendor or any type of thinking, I would say. When you're picking and choosing which ones to use, I'll give one example from when I was at the Major Facilities Workshop in March, and one of the facilities, their researchers are out on ships at sea. Sounds very cool. They have a lot of computing equipment on those ships. They don't need to be going back and forth to the cloud over expensive satellite connections when they can do that compute on the ship. But when they get into port and they've got all that data and they want to share that with their peers, what makes more sense? Uploading that to a central spot in the cloud or shipping hard drives around the world? I think that one speaks for itself. So look for the right use cases for cloud. And if you've identified a workflow that's well suited for the cloud, if possible, try and do it natively. And by that, I mean, build it out in the cloud. Don't just move it there, because I'm sure you've all heard the term lift and shift. To just pick up something and drop it in the cloud is the least efficient way to use the cloud. Now, in some cases, that's your only choice. You move it up there, and then you go through some periods of optimization to make it more and more cloud native. And eventually you'll get to that more efficient state. But whenever possible, try and do it natively from the start. And then finally, training, education. Training, I think, is vital. So don't do it in a vacuum. I think experience is the best teacher. If you have a production project ready, go through your training and then jump right in on that production project and take it to the cloud, so that you and the folks in all the supporting positions, your networking, security, developers, all that are working together to make it happen. And I think that's the best way to proceed.
Thank you, Bob.